So the new and the effective topic for the joint is the eccentric loaded bolted jointed shear. First we'll take a now here in structure group you can see that in this figure, okay, in this figure you can see that A1, A2 and A3, A4, A5 are the cross-section area of a bolt. Here is the area. It's A1, A2 is nothing but the area. It is the cross-section area of a bolt having a coordinates of x1, y1 and x2, y2 up to x5, y5. So based on this, the x bar at the center of gravity is located by symmetry. This, so it is can be calculated by a1 x1 plus a2 x2 up to a5 x5 divided by a1 plus a2 up to a5. So x bar is equal to what? Summation of ai xi divided by summation of ai, and y bar is equal to what? Summation of ai yi divided by summation of ai. So this is how we get this thing, that is the x and the y value. So if suppose just take a figure here, this is a bracket which is bolted here on a wall having 4 bolts, that is 1, 2, 3 and 4. The center of gravity is G here and eccentric load P is acting here at a distance E. So based on that, what will be the movement? Movement will be what? P into E. So P1 dash, P2 dash, that is the nothing but primary shear force due to the gravity. So this primary shear force is what? P1 dash, P2 dash is equal to P upon number of bolts. So if you have 4 bolts are that, it is P upon 4. This will be the primary shear force. That is a load upon area. Okay. For the secondary shear force, that is P1 double dash, P2 double dash and all this, that dash is shown here, which results in secondary force, that is due to the movement, that is P into E is nothing but the movement, and due to this the center of gravity results in secondary shear force, and this secondary shear force is given by a relation P1 R1, P2 double dash R2, P3 double dash R3 and P4 double dash R4. So based on this you will get here. So now it is assumed that the secondary shear force at any bolt is proportional to the distance from the center of gravity. So we have one constant here, that is C. P1 double dash is what? C into R1, like this. P4 double dash equal to C into R4. Now this B into A, that is this terms into this and this, if we join together, what we get? C is equal to PE upon R1 square plus R2 square plus R3 square by R4 square. Now by putting these values here in these terms, okay, if this is the C term, this is A term, this is B term and this is C term. So if you put this value in the above equation, it is P1 double dash, you will get P1 double dash is equal to PE R1 divided by R1 square plus R2 square plus R3 square up to R4 square. This is how you will get the secondary forces. So in this analysis, it is assumed that the component connected by the bolts are rigid and the bolts have the same cross-sectional area. Okay, so this is very simple topic of eccentrically loaded bolted jointed shear. Thank you.